Okay, guys, here's where we were left off right before spring break. Excuse me. Some classes made it this far, some classes did not. So we're just covering this for those classes that didn't get to it. If you already covered this one, you can fast forward to where we get to today's lesson. Well, on this one, if I have a subway or local bus ride is $2.50 for one ride, how much would it cost me? So, $2.50. Have me worried there for a second, Solo. So how much is 2 rides going to cost me? 3 rides? 4 rides? 5 rides? 10 rides? How'd you get that?
I multiplied 250 by 10 times.
Okay, that's one way to do it. Personally, I would have just taken the 2 and done times 5. What about for 30 rides?
75.
How did you get that?
I multiplied 25 by 3.
Good. So what if I have some number R of rides? How would I figure out what the total would be? So how would I write that?
R times 2. Wait, 250 times R.
So 250 times R? Like that? Because that's not what you said initially.
I changed my mind because I realized I was wrong.
Why were you wrong?
Because you can't have 4 numbers. You have
Good. So in this case, what's the mathematical term for that $2.50? Gian? Awesome. Coefficient. Remember that, guys. So for those of you that wanted to write it as R250, that is wrong. Coefficient always comes first. So, yes, sir. R is the number of rides. So that R represent the number of rides. What is the expression that shows the cost? That's what we just came up with, the $2.50 times R. So use the expression to find out how much money 60 rides would cost. So how much is 60 rides?
$50.
How did you get that?
I multiplied 75 by 2.
But what did it tell us to do?
I multiplied 75.
Said use the expression. So let's actually use the expression, $2.50 times 60. When I multiply decimals, what's the first thing we need to do?
Take out the decimals.
How do I do that?
You just kind of erase the dot.
He's right. We kind of mentally erase the dot, but we do something to show that we've erased the dot. What is it? Good. I write a 2 up here to show that I have 2 decimal places, and then I mentally erase the dot. I don't have to physically do it, but I'm not going to do anything with it, right? So now I'm just multiplying 250 times 6. So put my 0 for the tens place. 6 times 0 is 0. 6 times 5 is 30. 6 times 12 is 6 times 2 is 12, plus 3 is 15. Once I finish the math, now I put my 2 decimal places back in. So how much was it? $150. Now, that being said, what I think it was Devin had initially done would get you the correct answer. If I just doubled the 30 with $75, double that, I know what I've got, right? So that would work. You could also have done, 10, I could do that 25 times 6, I'd get the same thing. So whatever way you wanted to manipulate the numbers in the table will get you the answers. That's why the tables are beneficial, guys. So if a commuter spends $175 on bus rides, how many trips did the commuter take?
70 trips.
How did you get that? Hold on, Sean's answering.
Alright, so the last one was 150. You need to get to 175. You add the $25 from the 10 in number of rides. So if $60 or 60 rides was $150, you add the 10 rides.
Good. So Sean utilized the table and the data that we just had. He said, 60 was 150. I need 25 past that. Well, another $25 is another 10 rides. So I take the 60 rides, add the 10 rides, and I get to 70 rides. Does everybody track on that? Does that make sense to everybody? Anybody who doesn't understand the magic voodoo we just did? Just you, David? Once I'm actually multiplying, that's okay. When I'm writing an expression, it's not. Yes. Okay, now here's where we're really going to test your memories.
Can I do it?
No. Sean, you can't do it either.
What?
Because you said you already had the page done.
Yeah.
That means you guys did this while we were talking about it. So for all the rest of you, shh,
No.
quiet. How is Part D different from Part C? No, I told you, you two can't answer.
I'm in bed.
No.
It was magic voodoo.
It is magic voodoo. Math is full of magic voodoo. That's what makes it so marvelous.
Isn't it voodoo magic? Divided by I.
1. Yes.
Isn't it voodoo magic, not magic voodoo?
Commutative property of voodoo. It works either way. This is going to be a really fun recording. I hope people are actually listening. Guys, seriously, nobody? David. That's a very interesting answer, David. I would almost be tempted to explore that. Is that all? Okay. Okay. So what did we call that? We put a math term to it. So Isabel was perfectly right. So for those of you that couldn't hear her, she said in part C, we knew how many rides, we needed to find out the money. Part D, we knew how much money we needed to find out the rides. So what do we use to be able to find that? We gave you a math term that describes what we did. So? No. David? Nope. T? Inverse operations.
I literally said it, but it was you have to think
They are inverse operations. So Isabella figured that out. She understood the concept and just wanted to put the math term to it. So good job. Okay, here's where we're going to challenge you a little bit. So pendulum swings to a certain number of cycles in a given time. Owen made a chart. Uh-oh. Okay, I can't read that part, but basically I believe it says it makes a cycle 12 times every 15 seconds. Construct a table showing the number of cycles through which pendulum swings something in 1 minute. Use the last row for C cycles. Write an expression for the time it takes the pendulum to make C cycles. Okay? So we have C is the number of cycles. And S, which is the number of seconds. So our first entry, we learned that it does 12 cycles in 15 seconds, correct?
Wait, so one swing is a cycle? Is one swing a cycle?
Yes.
Okay.
So normally a cycle is when it goes over and back. That's a cycle. So it's saying it does that 12 times every 15 seconds. Right. Yes. Yeah, go sign out. Okay, so what would my next entry in my chart be?
2430.
2430, right? My next entry would be 3645. And my next one would be
48.
4860, because it said it would make it for 1 minute, right? Then it says it wants to use the last row for C. So if I have C cycles, how many seconds is it going to take? What's the relationship in between these?
Plus 3.
C plus 3?
No, that won't work.
No, that won't work.
That wouldn't work? What's the relationship? How do I go from the cycles to the seconds?
I feel like I should know this.
I feel like you should know it too.
Can I tell so I can figure it out?
What is that?
I've already given you almost a minute.
What was the question again?
If I have C number of cycles, what do I do to find out how many seconds there are?
Wait, I think I've got it, but this will sound really confusing. Because
Okay.
I don't know how to phrase it correctly. It is C plus in parentheses 3 times the wait, hold on. So you know the 4 things on the side. What are those called?
The 4 things.
24, 36, 48.
That's the number of cycles.
Yeah, but if you were to go to the left of that and put 1, 2, 3, 4, the number of boxes. So it'd be C plus 3.
Oh, the rows?
Number of boxes. Yeah. And so
Okay, so what am I doing?
on the first one it would be C plus 3 times 1 because that is the first row.
Okay.
On the next one, it would be C plus 3 times 2 because that is the second row, and so on.
You totally lost me, I'll be honest.
It's complicated.
And that's tough to lose me mathematically.
I know. It's actually
Okay, I understand this concept. He's saying what I'm doing is using the number of rows, but he's saying C times,
times the number that row is.
okay, so times row 1,
Yeah, so it'd be C plus 3 times 1 for row 1.
but it's not.
Yeah, it would, because if C is 12, plus 3 times 1 is 15.
Okay, what about 2?
C plus 3 times 2, because row 2. Okay. C plus 6, 24, and 30. It does work.
Okay, I see what you're saying. Okay, so you're actually really close to what you need to do. You're understanding that there's a relationship between these 2 rows, right? You're just having trouble defining what that relationship is.
I've already made one that's just different from what you
Okay,
did.
but we can do a direct relationship. What would I multiply this by to get this number? Sean?
So it's C times 1 and 2 tenths.
No, 1.25.
No.
Yeah, it'd be C times 1.
Here's the easy way to do it, guys. If I need to get this number, it needs to be left after I multiply, right?
It needs to be what?
Needs to be left. This needs to be the number that's left after I multiply, right? How do I do that? I make that my numerator.
1.618.
Because now if C is 12, the 12s are going to cancel out. I'm left with 15. If C is 24, now that becomes a 2. 2 times 15 is 30. So this is doing what you were wanting to do, but now it's showing the direct relationship. Can I simplify this?
Yeah.
Yes, I can divide both of them by 3. That gives me 5/4, which I can also simplify, turn it into a mixed number, 1 1/4, which is what Sean came up with. That's equivalent to 1.25, right? 1 1/4.
Wait, isn't that what I said, though? Yeah, I said that. I said 1.25 times C.
Yes.
Said, 0.20 because I was using the 15 and not the 12.
Okay, yeah, you're going the wrong way.
I found it before.
So Owen and his pendulum test and count 60 cycles. What was the elapsed time? So now I need to do is put 16 in there. So I do 5/4 times 16. How do I multiply fractions? Fractions and whole numbers?
You kind of just dissolve the decimal point. Oh wait, are we dividing the
Multiplying.
Then, yeah, take out the decimal point and write a 2 with a...
There is no decimal point. It's 5/4.
Oh, fraction.
Fractions. 5 times 4 is 20 seconds. Oh, we're going to get lots of practice on fractions today.
I'm about to have a seizure.
Okay, now we have 1 and 1/4 C, but now I'm going to go the other way. Now I want to write an expression for the number of cycles in S seconds. So now I'm going the other way. I'm going to say S on this side. What do I do on this side to find the S? I'll give you a hint. We just talked about it at the bottom of the last page, right? Inverse operations. So I divide by, instead of multiplying by 5/4, I divide by. But do we divide fractions? Really? We do what? Hold on, Isaiah's got it. Multiply by? What do we call it? Multiply by the, what's the math term?
Oh, I know it.
We don't divide, we multiply by the, no, what's the math term? Caden? You have your hand up, waving. Guys, remember, if I did 2 divided by 1/2, did we actually divide by 1/2? No, what did we do?
We divided by an improper fraction. Improper fraction, yes.
Multiply by what? What did we call that? What did we call that? How were those numbers related? Jen? No. It is an improper fraction, but how are those two numbers related? What do we call them? I'll give you a hint. If I multiply 1/2 times 2/1, what do I get?
I know. I
Whole number.
What's the math term for these? Sean? No. David, don't lean in your chair. An integer is any whole number, positive or negative. Include a plus 0. Guys, what was that math term? We don't divide fractions, we multiply by the... Reciprocal. Okay. So, what is the reciprocal of 5/4? 4/5. So, instead of dividing by 5/4, I multiply by 4/5 S.
Or you can divide by 1 in 2500.
You could. So, is this all bringing stuff back to you, hopefully? So, in a different one, they counted the cycles for 35 seconds. How many cycles did they count? Now I can use this expression, 4/5 times 35. I have to do whole numbers over 1. Now I can reduce. 4 times 7 is 28 cycles. Does this make sense, guys? I know, math is completely logical. That's why I love it. I do like math.
Because there's always
if I give you this problem and you answer 20, you're wrong. It's 28. There's only one answer. It's not like, not to bash social studies, but if they ask you what is a tenet of Christianity, and you give something that's at least semi-close, they give you credit. I have an exact answer. You don't say 28, you're wrong. It makes my grading really easy. I do hate estimating, I have to admit. But there is some good purpose to estimating. I literally estimate every time I go shopping.
Overestimating.
No.
Overrated estimating.
Okay, guys, we'll have another one here. Go ahead and turn to page 96 in your modules. I do want you guys to work this one as a table, and then we'll talk about it. Guys, come on now. I will admit, I've seen a lot of constructive struggle on this, which I really appreciate. Here's our deal. Again, if we mark our text, it's going to help us. They have square tables that servers can push together to accommodate the customers. When they do so, only one chair fits along the side of the square table. What that means is each side can have one chair. So make a model of each situation to determine how many seats will fit in various situations. So what this piece here is saying, guys, is I can only put one chair on each side of the table. Make sense?
Yeah.
Okay? So if I have one table, how many seats do I have?
4.
Does everybody see that?
Yeah.
Okay, so now if I push the two together, I've got
6.
how many?
6.
6. If I put 3 together, now I've got 8. Okay, so then 10, then 12, then what? Lily, 102. And then for 200, I would have. So my total number T, how do I figure that out?
T times 2 plus 2.
Devin, I'm going to write that just the way you said it.
Wait, no. 2 times T plus 2.
No, that's not what you said.
I changed my mind.
It's 2 plus 1 times T. So let's
2 times T plus 2.
Hold on, guys. Too much talking going on. So, Lydia, what are you saying?
I wrote 2 plus 2 times T.
That's not right.
So you said 2 plus 2 times T, like that?
No, that's not right.
What's wrong with that?
Because then, oh wait, no, that is right.
Wait, I don't know anymore.
Did you have any parentheses, Lydia? That's my big question.
Oh yeah.
From the way you said that.
No, I didn't.
No parentheses, so that's what you wrote. 2 plus 2 times T.
Now it's correct.
Put parentheses where?
No, that's not.
Why? Guys, listen up.
You multiply 2 and 2, and then you add the 2.
But I'd do that anyway, right? Order of operations, does it really matter which way I wrote that? So could I have written this, changed what Devin said, 2T plus 2? It's a. So, as we were talking about right before you guys left for lunch, we now have the expression of 2T plus 2. So let's just check it again. So if I do 2 times 1 is 2 plus 2 is 4. 2 times 2 is 4 plus 2 is 6. 2 times 4 is 8 plus 2 is 10. 2 times 50 is 100 plus 2 is 102. 2 times 200 is 400 plus 2 is 402. Good. So it looks like we're good on that. So this was just kind of a way for you to walk through this. So it's impractical to make a model of 50 tables, but if we did have a rectangle that long, how many chairs would fit on the long sides of those tables?
50 on each side.
So how many is that?
100.
So 100 chairs on the sides. Does that make sense to everybody? Good. how many chairs can I put at the ends?
2.
2. So how many should fit on the ends of the table? 2 chairs. So how many chairs fit in all? 102. Makes sense? So we put that one on the table already. Now what if we made it a 200 square table? How many are going to fit on each side?
400.
400, because I got 2 sides, right? And then, if we still have the 2 on the end, so 400 on the sides, 2 on the end gives us a total of 402. Does that make sense? So for those of you who didn't have all those numbers in your table, do you now understand why those are the numbers that you should have had? Is it making sense?
A little bit.
Okay. So if we let T represent the number of square tables at one long rectangular table, what is the expression for the number of chairs that will fit around it?
2T plus 2.
2T, because each table I only add 2 seats, but then I always have the 2 at the end that I need to account for. Does that make sense? Good. Let's go ahead and turn the page. Now, I'm going to give you guys a few minutes now that you've got that concept going through your head on these tables. Go ahead and work this one together and see if you can figure out these charts. I'll give you 3. Who was able to fill out the table? What did you get?
I got for number 1 it's 6,
Okay.
then 10.
Whoops, hold on. Let me switch pens.
Yeah.
Okay, we had 6, then 10.
14. 18. 60. 300. 4P plus 2. That's the time plus 2. 4P plus 2.
Okay, does this look like everybody else's chart? No? No, what's different for yours, Jayla? Oh, you did 12? Okay. So then 12 you had, then what? Okay, then.
I see what they did already.
I do too.
Yeah, it wouldn't be 12, it would be 10. Because 2 pizzas equals...
Hold on.
Plus what?
Hey, Caden.
Wait, they charge $2 to deliver?
Yeah, $2. $2 regardless of how many pizzas are ordered.
Oh, okay. So, like, got his name, Devin. Like Devin said, it is $10 because it's two pizzas which equals $4, but then $2 of delivery.
No, 2 pizzas equals $8.
Yeah, 8, then $2 delivery.
Okay.
$10.
Sean?
I got a different payment for 10 and 50 pizzas.
You did?
Oh, yeah.
What did you get for 10?
$42.
42.
But that's wrong, too. Whoa.
And for 50 you got
$202.
200. That's a big difference. That's like a $98 difference. So how did Devin mess up so badly? The? He just took the easy way. He said 6 times 10 is 60. 6 times 50 is 300.
That's what he did, but that's not.
But that's not what he was supposed to do. Ironically, he came up with the right formula,
He didn't use the correct.
but he didn't use the formula. He looked for that shortcut of saying, oh, there's my numbers. You do so well all the time, Devin, that honestly it's good for everybody else to see that no one's here is perfect, that you make mistakes as well. No! This is like going to be my most liked recording of the year, because we're going to let everybody know you got to hear how bad Devin messed up.
Wasn't me messing up on 4 and Bisbo's enough?
No, that was fun, though. Okay, so Sean just stole my thunder. I was going to go ahead and put 10 into our formula and see that it was actually 42. 50 into our formula and see that it's actually 202.
I like taking people under.
Make sense? Okay. So what let me try this again. What mathematical operations did you need to perform to find the total cost? What did we do? Sean?
Multiplication and addition.
Good. Multiplication? Hey guys, please stop the chatter. Multiplication and addition. We had to do both, right? So suppose our principal wanted to buy a pizza for everyone in our class. How much would that cost? So how many people are in our class? We've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Oh, 25, exactly. Do what?
Liam doesn't get it.
Liam's not here. So in our class,
got here, so if they did it before lunch.
did it before lunch, you'd have a slightly different answer, but I doubt many of you did. So if I had 25, it's 25 times what?
25 times P.
Which is?
4.
4. No, P is 25.
Yeah, he is 25.
Plus what?
2.
So how much is it going to cost? $102. Make sense? Now we look the other way. The Booster Club had $400 to spend on pizza. What's the greatest number of pizzas they could order?
Well, we know it's not 100 because of the extra $2. So doesn't it have to be 99?
I like your logic. So we know it can't be 100 because 100 times 4 would be exactly 400, but we have to account for that delivery charge. The delivery charge is less than one whole pizza, right? So just take one pizza off, we get 99, and we still have the delivery charge covered. Now, we haven't covered this yet, but why is that delivery charge so important? If I order a pizza, the delivery guy comes and delivers it. If I ordered 4 pizzas, is he going to drop one off, go back to the store, and come back to my house again? No. So that's why there's only one charge, because he's only coming one time. So the pizza owner only has to pay that guy one time to make that trip to bring me the pizza. It doesn't matter how many I order because he can carry them in his car. Now, if I was actually ordering 50, then it may become an issue. But normally when businesses do this kind of thing, they look in scale, and just to keep everything easier for themselves, it's one charge regardless. It makes it easier for everybody involved. So that's why you only have that one-time cost, because he's not making multiple trips to deliver all the pizzas. It's just one trip. But he does have to charge me for each additional pizza that I order, because now he's making something, right? So does that help you understand how this whole all works together? Okay, look on. Oh, that's it? Oh, no, here it is. I thought we had one more to do. Okay, I'm going to give you guys just a couple more minutes to do this table. Now that you have that. Okay, we've already had some experience. This one should have been an easy table, right? What's my first one? 8, then?
13.
Then?
18.
Then?
23.
Then?
28.
Then?
5P plus 3. Well,
Thank you for even saying it in the correct order. And then just double check, because it's always good to double check. So I put it in. 5 times 1 is 5 plus 3 is 8. 5 times 2 is 10 plus 3 is 13. 5 times 3 is 15 plus 3 is 18. Looks like it's good. Any questions on those? Okay, turn to the next page. Homework. These are pretty simple. They do follow exactly what we just did. Pay attention to anything that is added. A one-time charge is going to be an adding. Anytime I'm doing an each, that's going to be a multiplying. Okay? So $12 each, we're talking multiplying, $4.50 for shipping. Regardless means that's a one-time charge. Any one-time charges are added because that's a one-time thing. Remember, multiplication is something that's done repeatedly. Do I pay that extra charge every time? No. So how I account for that is with the addition piece. See if there's any other tricks in this one. This one is pretty straightforward again. The costs are $2.95 each. One-time charge of $4. So then you can build an expression off of that one. This one, I've already seen some students that struggled on this. She had $450 in gifts and saves $120 per week. So just because she's only earning $120 per week, she still has that initial amount that was given to her that needs to be accounted for as you're building up that one. And then your last one, words per minute are read by each of the students. They collect it, assuming the increase continues throughout the rest of the school year. So they basically set a baseline and then figured out how much they were able to increase each month. So yeah, the hard part on this one is figuring out what that baseline was. What is it you're adding each time? Remember, what I'm adding each time, that's my repeated piece, that's my multiplication. That initial piece that I'm adding in will be the addition piece of it. Yes, sir?
Why is Caitlin sitting there and so I'm sitting here?
Because they switched spot seats.
So you can get away from me. So can I?
No.
Can I?
No. Okay, so